So today's lesson is on modeling with linear equations. Today is Thursday, October 20th. So you know that when we write equations from word problems, we typically write our equations typically in the form y equals mx plus b. We always look for our slope. Remember, our slope in a word problem is often identified by the word per or every or rate. And B, the y-intercept, is identified by flat fee, or it might say beginning cost, something like that, okay? So, for example, number one, it says Janine has $450 in her savings account at the beginning of the year. So at the beginning of the year, she has $450. That's the B. She places money in her account at a rate of $5 per week. That is our M. So the first thing that I want to do is just write a general equation in the form y equals mx plus b. So y equals m, which is $5, times x plus b, which is 450. So the directions actually to write an equation to model the amount of money she has in her savings, S, that would replace the Y. 5 times for the function in the number of weeks, W. So instead of X, we're going to use W plus 450. So the first thing that we want to do is fill out a table. So I'm just plugging in, I'm kind of using this 5W plus 450. So if W is 0, 5 times 0 plus 450 is just that, 450. If I have money for 1 week, 5 times 1 is 5, plus 450 is 455. If I save money for 5 weeks, 5 times 5 is 25, plus 450 is 475. And if I save money for 10 weeks, 5 times 10 is 50, plus 450 is 500. So we've already written our equation, S equals 5W plus 450, which really just came from the y equals mx plus b equation, that slope-intercept form. It says if Janine saves for exactly 1 year, what is the range in her savings over the year? So if she saves for 1 year, that means let W, the number of weeks, equal 52. So let's calculate that first. So the total amount in her savings is 5 times 52, that's the number of weeks, plus 450. So I'm going to use my calculator. 5 times 52 plus 450 equals $710. So the total amount in her savings is $710. So this is asking for the range, meaning the difference from the smallest to the largest, not the range, which is the y values compared to like the domain. But we still are looking at the range, the amount of money in her savings, which is S. So when we talk about the range, we want to look at the most amount of money she had in her savings account and the least amount of money she had in her savings account. So we could say that the money in her savings ranges from $450 to $710. Okay? 450 to 710. If we were required to list it, we would really have to list every increment of 5 coming after the 450. So this range is just perfect. Why would it not make sense to evaluate S at 6.5? Meaning, why can I not let the number of weeks equal 6.5? Well, it's because we're only depositing in money one time a week, and we're depositing it in at the beginning of the week, right? So we can't do a half of a week. We're doing whole weeks. So we need to have whole numbers as our input. And we need to make sure that these numbers are positive because we aren't putting in for negative weeks. So what types of numbers belong to the domain? Well, the domain, the X value or the inputs are positive whole numbers. So use 2 points from the table to verify that the rate of change of the function is $5. So I'm going to use the point 1 and 455. And then I'm going to use the point 5 and 475. So I'm going to set up the y2 minus y1 over x2 minus x1. So y2, 475 minus y1, 455 over 5 x2 minus x1, 1. So 475 minus 455 is 20. 5 minus 1 is 4, and 20 divided by 4 is 5. So these are the same. All right, let's look at another example. So water is building up in a bathtub. After 2 minutes, there are 12 gallons. That looks like an ordered pair. 2 minutes, 12 gallons. After 4 minutes, there are 20 gallons. We need to find the rate of change. So I'm going to do this one like a table. 2, 12, 4, and 20. So let's see. On the Y side, I add 8. And on the X side, I add 2. 8 over 2 equals 4, which means that I am adding 4 gallons per minute. All right, Francisco is saving money in an account. At the beginning of the year, B is 56. And then she puts in $4, and then he puts in $4 per week. That's my M. So if I write this as Y equals M, 4, times X plus B, 56, and then I change it to the variables that's listed. I want S to be the total amount in my savings, equals 4 times W, the number of weeks. So my equation looks like it is A. Example number 3 says Maria charges $15 for every 2 hours. So that means that when X is 2, the money coming in or the money made is 15. So let's see, I'm going to plot that point right now, 2, 15. How much would Maria make if she worked 5 hours? Well, let's figure out what she's making per hour. So 15 divided by 2 is 7.5. So that means that she makes $7.5 per hour. 7.5 times 5 is $37.50. So if she worked for 5 hours, she would make $37.50. How much would she make if she didn't work any hours? She would make $0. How much would she make if she worked 4 hours? Well, 4 times 7.5 is 30. So let's plot that point. How much would she make if she worked 6 hours? Well, 6 times 7.5 is 45. How much would she make if she worked 8 hours? 8 times 7.5 is 60. If she worked 10 hours, 10 times 7.5 is 75. And if she worked for 12 hours, 12 times 7.5 is 90. So if I plot those points, let's see, 2 hours is 15, 4 hours is 30, 6 hours is 45, 8 hours is 60, 10 hours is, let's see, 75, and 12 hours is 90. Okay, so I've graphed my relationship. It says write an equation for the amount A that Maria makes as a function in the number of hours that she babysits. Keep in mind that if she doesn't babysit at all, she makes $0. So that's just saying, remember that means that the beginning amount is 0. And that makes sense because I crossed the y-axis at 0. So all I need to know is my slope in this. And remember we said that our rate is 7.5. So if I used y and x, this would look like y equals my slope, m, times x plus b, which is 0. But instead, I want to use the variables that they gave me. The total amount in her account equals my slope, or my rate, times the number of hours that I work. And I'm not going to write the plus 0 because we just don't typically add 0. So that's my function that I'm going to use to model this graph. All right, so a water tank is being filled by pumps at a constant rate. The volume in the water tank, V, in gallons, is given by the equation V of T. So V is a function of the time, 65 times T plus 280, and T, the time, is happening in minutes. So at what rate, this means what is the slope that the water is being pumped in per minute? Well, the slope is 65. So it's 65 gallons per minute. Remember, a rate has 2 units. 65 gallons per minute. How many gallons of water were in the tank when the pumps first started? Well, that's my beginning amount. That's B. So there were 280 gallons in the tank at the beginning. What is the volume in the tank after 2 hours? Well, 2 hours is equivalent to 120 minutes. So that just means let x equal 120. And we're going to evaluate this function. So V of 120, and actually I'm going to change that from saying let x to saying let t equal 120. So V of 120 equals 65 times 120 plus 280. So the volume at 120 minutes is 65 times 120 plus 280, 8,080 gallons. The pumps will turn off when the volume in the tank hits 10,000 gallons. This means let V of T equal 10,000. So we're trying to figure out how many minutes, how long is this going to take? And we're going to round to the nearest minute, the nearest whole minute. So instead of starting my function with V of T, I'm starting it with 10,000. I need to change that, sorry. So 10,000 equals 65T plus 280. So I'm going to subtract 280 from both sides. So 10,000 minus 280 equals 9,720. Divide both sides by 65. So 9,720 divided by 65 is, the time is 149.5. So if we round it to the nearest whole minute, we're going to say it's 150 minutes. So after 150 minutes, or 2.5 hours, the pumps will shut off. All right, example number 2. A solar lease customer built up an excess of 6,500 kilowatt hours during the summer months. So this is the beginning amount. B equals 6,500. During the summer using his solar panels. But when he turned his electric heat on, the excess began to get used up. So because I'm using it, my slope is going to be negative. I'm not adding to the beginning amount. I'm taking away from the beginning amount. So if I were to write this in slope-intercept form, y equals negative 50 x plus 6,500. However, I have to use the specialized variables E represents the total amount, the excess, and then we're letting D represent the number of days. So E, the excess, equals negative 50 times the number of days plus 6,500. So there's my equation. How much of the excess will be left after 1 month? So that means let D equal 30 days. So E equals negative 50 times 30 plus 6,500. E equals negative 1,500 plus 6,500. E equals 5,000 kilowatt hours. If the heat that you need is going to be turned on for 5 months, will the excess be enough? So let's look at our equation. E equals negative 50D plus 6,500. But I'm running my heater for 5 months, or 5 times 30. So that's 150 days. So I have to let D equal 150, right? So E equals negative 50 times 150 plus 6,500. E equals negative 7,500 plus 6,500. E equals negative 1,000. So what does that mean in terms of our example? Well, what it means is that we are actually going to be in the hole or run out of energy. We're not going to have enough. We're actually going to be 1,000 kilowatt hours short. That's why it's negative for the 5-month requirement. Okay. All right. So let's look at some graphs and let's try to represent some graphs. So this graph just represents the elevation in Bryce Canyon after these two people traveled through Bryce Canyon. This is their time in minutes and their elevation. So the first thing I want you to notice is that they started at 71, 72, 73, 74, 75, 76, 77, 78. They started at about 7,800 feet. That was their starting elevation. They got as low as 7,200 feet, and they got as high as 9,300 feet. Okay, so we're going to answer questions. So it says identify the domain and the range of the function. So that's the first thing that we're going to do. Well, let's see our domain. Remember, that's our x values. So all of our x values are greater than or equal to 0. Our range values, well, all of our range values, really, our y values are greater than or equal to 7,200. But we could also say that they're greater than or equal to 0, depending on how particular you want to be with the graph, okay? Is this discrete or continuous? Well, it's continuous. Remember that if it's discrete, I would just have points on my graph, and I don't have points. I actually have a line, so this is continuous. So while at Bryce Canyon, George and Jackie went hiking under the Rim Trail. The table shows their progress down the Yellow Creek. The grid is provided to help you. So at 0 minutes, they were at 7,900. So this is a different part of the canyon. So when they first started this hike, they were at 7,900 feet. After 10 minutes, they were down to 7,500 feet. After 20 minutes, they were at 7,100 feet. And after 30 minutes, they were at 6,700 feet. So continuous. Says find the slope. Well, remember that our slope is our change in y minus 400 over our change in x plus 10. So my slope, negative 400 over 10 equals negative 40. So interpret the slope as a rate of change. So it's descending, because this is talking about elevation. So they are descending 40 feet each minute. So those are my units, or 40 feet per minute, descending 40 feet each minute or per minute. On the descent, what was the elevation after 18 minutes? Justify your answer. Well, we know that our slope is negative 40. We know that our beginning value is 7,900. So let's write an equation for that. That's the equation y equals negative 40x plus 7,900. So this says, well, let x equal 18. So y, my total elevation, is negative 40 times 18 plus 7,900. So negative 40 times 18 plus 7,900. So our elevation after 18 minutes was 7,180 feet. On the descent, when were they at 7,000 feet? Well, according to my graph, it's about right here. So if I look at that, 22, 23, I'm going to say it's about 24 minutes. That's my guess from the graph, about 24 minutes. But of course, I want to prove that. So I'm going to use my equation, y equals negative 40x plus 7,900. But this says, let y equal 7,000. So 7,000 equals negative 40x plus 7,900. I am going to subtract 7,900 from both sides. So I have negative 900 equals negative 40x. Divide both sides by negative 40. So 900 divided by 40 is 22.5 minutes. So after 22 and a half minutes, they will be at an elevation of 7,000 feet. So here is your homework. You have number 1, number 2, again, number 1, number 2, number 3, number 1, number 2, and number 3. Okay, and then you can stop. All right, good luck.